Hello dear students, welcome all of you to Unique World Group of Education Dubai. This is Faslur Rahman, Chemistry Faculty of Unique World Education. I hope all of you are fine and I hope all of you like chemistry very well. So today we are going to learn a very important chapter from grade 11 chemistry. Okay, so I hope all of you know there are three parts of chemistry, like organic chemistry is there, inorganic chemistry is there, and physical chemistry is there. So which area of chemistry you people like more? So I hope all of you prefer inorganic chemistry because that is very easy to study, like this one, biology. Anyway, you have to give equal priority to organic chemistry and physical chemistry as well, because most of the questions from your for your board exam and entrance exams and all will be from organic chemistry and physical chemistry. So please be very perfect with your organic reactions and physical chemistry calculations as well. So what we are going to do today means we'll learn a small topic from physical chemistry, redox reactions chapter. So I hope all of you know the chapter redox reactions. It's a very simple chapter, very small chapter, but still is a very important chapter. We have many important concepts in that chapter. Clear? So redox reactions, redox reactions. I hope all of you are familiar with the word redox. So we can start redox reactions. Okay. So we are just starting with a random topic today. So you can come in comment box and mention your opinion, like which chapter you need next or which topic exactly you need. Okay. Or which topic you feel difficulty in learning. So we can discuss that. No worries. Clear? Okay. Coming to this chapter, all of you know about redox reactions, right? You have studied in grade 10 itself. So redox reaction means a chemical reaction in which oxidation and reduction takes place simultaneously. All of you know that. Oxidation and reduction takes place at the same time. Okay, and you should know exactly about what is mean by oxidation and what is mean by reduction. That is very important. So without knowing this basics, you can't do the balancing and all in this chapter. So coming to oxidation, actually we can define oxidation and reduction in many ways. So I'm giving some important definitions here. Many definitions are there. So first one, oxidation means addition of oxygen. Addition of oxygen. Okay, adding oxygen to any species is considered as oxidation. And second one, loss of electron. Loss of electrons, that's a very important definition. Losing electron from an atom or species is considered as oxidation. And third one, increase in oxidation number. Increase in oxidation number. Okay, so all these concepts are very important in this chapter. So without knowing what is oxidation and what is reduction, you can't do anything in this chapter. Okay, so not only for this chapter, there is the basics of chemistry. So that's why I selected this particular topic today. So the opposite of all this will be what? Reduction. So reduction means removal of oxygen. Okay, removal of oxygen, gaining of electron, and decrease in oxidation number. Decrease in oxidation number. Clear? I will give you some examples, then you will get more idea about this. For example, if you want to calculate the oxidation number of any element in a compound, how we can do that means, for example, potassium permanganate. All of you know about potassium permanganate, right? It's a very important chemical which is used in many chemical reactions and all. What is the formula of potassium permanganate? That is KMnO4. KMnO4. Potassium permanganate. So charge of potassium, all of you know. All of you know about the charge of potassium because potassium is coming in which group in periodic table? First group. First group, potassium is an alkali metal, right? All the alkali metals are having plus one oxidation state. I hope all of you know that because they are having one electron in the outer shell, right? So potassium, charge of potassium is plus one. All the elements in group 1 will be having plus 1 oxidation state, and charge of oxygen in most cases it is minus 2. Minus 2 only in some cases like peroxides, superoxides and all, it will be different. So oxygen is minus 2, minus 2. Okay, and you can assign x for the element for which you are going to find out the oxidation number. So for example, here potassium is plus 1, so 1 plus manganese I am giving x. X plus how many oxygen atoms are here? 4 oxygen atoms are here. So 4 times minus 2 is equal to 0. Why? Because this compound as whole is neutral. Okay, there is no charge. As a whole, that is a neutral compound. So equal to 0. Now you can easily solve the value of x from this one. Okay, so 1 plus x minus 8 is equal to 0. So x is equal to 8 minus 1 is equal to plus 7. Plus 7. So that means manganese in potassium permanganate is in plus 7 oxidation state. Got it? In this way, you can find out the oxidation number of any species from any compound. So you just assign x for that particular element, and using the oxidation numbers of the other elements in that compound, you can get the value of x. That's it. Okay. So potassium permanganate is a very important compound in chemistry, used in many chemical reactions and all, and moreover it's a very strong oxidizing agent. Strong oxidizing agent. Okay. Now we are going to balance a redox reaction. Okay, this is a very important part of this chapter, balancing redox reaction. So I hope this is clear how exactly we solved the oxidation number of manganese in potassium permanganate. Clear? So coming to the next topic, balancing of redox reaction. Next topic means this is the main topic in this chapter. So that's why I taught you how to calculate oxidation number first. Okay. So for balancing redox reaction, we have two methods. One is half reaction method. And second one is oxidation number method. Both are very important. So you can balance a redox reaction by either of these two ways. Clear? So we are going to balance the redox reaction using half reaction method now. Okay. So I will write the question here. So the question will be like this. Balance the following redox reaction using this specific method, maybe a half reaction method or oxidation number method, in acidic medium or basic medium. So they will specify the medium, either acidic or basic. Okay. So the question is like Cr2O7 2 minus plus Fe2 plus H plus gives Cr3 plus Fe3 plus H2O. This is the question. Clear? Yeah. So listen, this H plus indicates what? This H plus in the reactant side indicates the reaction is happening in acidic medium. Okay, acidic medium. And what you have to do first means you have to assign oxidation numbers for each and every species in the reaction. How's that? Listen. Chromium, like what we did just before, like how we calculated the oxidation number of manganese in potassium permanganate. So Cr2O7 2 minus. So I will just show you how to calculate that. We need to get the oxidation number of chromium in Cr2O7 2 minus. So we can put X for chromium. Okay. But listen, how many chromium atoms are present here? 2 chromium atoms. So we have to put 2X. So 2X plus 7 oxygen. So 7 times minus 2. Charge of oxygen is minus 2. Equal to, here you have to equate with this particular charge. That's very important. Not with 0. Because this is not neutral. This is having a charge. This is the ion. Which ion? This is dichromate ion. Cr2O7 2 minus means that is dichromate ion. So equal to minus 2. Equal to minus 2. So from this you can solve the value of X. How? 2X minus 14 is equal to minus 2. 2X minus 14 is equal to minus 2. 2X is equal to 14 minus 2 is equal to 12 plus 12. So 2X is equal to 12. So X is equal to plus 6. X is equal to plus 6. Clear? So the oxidation number of chromium in dichromate Cr2O7 2 minus is plus 6. I hope all of you clear. Okay. So yeah. Oxidation number of chromium is plus 6 and oxidation number of iron is Fe2 plus in the left side, that is already given, and chromium right side, that is Cr3 plus and iron Fe3 plus. Okay. Now what is the very first step means? You have to identify oxidation and reduction. Which is oxidation and which is reduction? So we can try that. Listen, I have given you the idea like increase in oxidation number is oxidation and decrease in oxidation number is reduction. So you can see oxidation number of chromium is decreasing from plus 6 to plus 3. Plus 6 to plus 3. Okay. So you can mark that like this. Clear? Because here left side chromium is in plus 6 oxidation state and right side chromium is in plus 3 oxidation state. That means oxidation number is reduced, decreased. Okay, so that is reduction. So you can mark like that is reduction. And what is happening to iron here? That is iron is in plus 2 oxidation state, that is increasing to plus 3 oxidation state. So you can mark that is oxidation. That is oxidation. So now we identified which is oxidation and which is reduction. Perfect. So now we can write, you have to write oxidation and separation reactions separately like two half equations. Okay. So I'm writing oxidation first. So always try to write the oxidation equation first. That will be better. Fe2 plus. Fe2 plus gives Fe3 plus and mention in bracket that is oxidation half. Oxidation half. Clear? And what is reduction? Reduction is Cr2O7 2 minus gives Cr3 plus. Gives Cr3 plus and that is reduction half. Reduction half. Clear? All of you clear? Okay. So we finished the very important basic first step. I think that's clear. Coming to the second step. Second step, you should balance all the atoms in the equation except oxygen and hydrogen. Okay. Balance, all of you know how to balance a normal chemical equation. Same thing. Okay. So oxygen and hydrogen balancing we will do at last. So you can balance the remaining atoms now. So in the first case, only iron atom is there and that is already balanced. So you can write that as such. Fe2 plus gives Fe3 plus. That's already balanced. No need to balance again. But second one you can observe, you can see here, that is two chromium atom left side, but you have only one chromium right side. So you need to balance that. Okay. So Cr2O7 2 minus gives 2Cr3 plus. Got it? So two chromium atoms left side, so you have to make right side also two chromium atom. So now that is balanced. I hope this is clear. Okay. What is the next step? In the next step you have to add electron. Add electron. Okay, so just wait. So you know, oxidation means losing electron, reduction means gaining electron. Reduction means gaining electron. So you have to mention in the equation how many electrons are lost and how many electrons are gained. That is the next step. Yeah. Okay. So can you please tell me Fe2 plus to Fe3 plus? Plus 2 to plus 3. How plus 2 oxidation state become plus 3 oxidation state? How many differences there? One unit, right? So oxidation means lose of electron, losing electron. So plus 2 to plus 3 means how many electrons are lost? One electron lost. One electron lost. Fe2 plus become Fe3 plus by losing one electron. That's it. Okay, so we can write that Fe2 plus Fe2 plus gives Fe3 plus plus electron. That means one electron. Got it? So always remember this thing. Whenever you are writing oxidation half equation, represent electrons after the arrow mark. That means right hand side of the equation. Okay? And coming to the next equation, Cr2O7 2 minus gives Cr3 plus. Listen, what is the oxidation number of chromium in Cr2O7 2 minus? That is plus 6. That already we found out. Okay, and that chromium in plus 6 oxidation state is changing to Cr3 plus. Right, Cr3 plus. So what is the change in oxidation number? Chromium is changing from plus 6 to plus 3. So how many electron? 3 electron. 3 electron, right? But listen, very important thing here you have to note. 2 chromium atoms are there. Okay, 2 chromium atoms are there. So 1 chromium 6 plus will gain 3 electron. Okay, so for example, Cr6 plus plus 3 electron become Cr3 plus. That is for 1 chromium, but you have how many chromium? 2 chromium. So what may be the total number of electrons gained? That is 6 electron. Clear? So you can write Cr2O7 2 minus plus 6 electron gives 2 Cr3 plus. That is the equation. Got it? I hope all of you are clear. Yeah. So Fe2 plus, I am repeating again, Fe2 plus become Fe3 plus by losing one electron. That is oxidation. Cr2O7 2 minus become 2 Cr3 plus by gaining 6 electron. That is reduction. Clear? Okay. Good. So we are moving to the next step. What is the next step? What is the next step? Yeah. Next step is, listen, in the first equation you can see only one electron is there. Okay. But in the second equation, you have 6 electrons. There is a mandatory rule like number of electrons in oxidation and reduction should be equal. Number of electrons involved, number of electrons lost and number of electrons gained should be equal. Okay, so you have to make that number of electrons equal on both cases. So what you can do, how you can make this particular number of electrons equal? See, by multiplying the first equation by 6, you can make that. So how will be that? 6 Fe2 plus gives 6 Fe3 plus 6 electron. Now you made the first equation also with 6 electron, and second equation will be same. So Cr2O7 2 minus plus 6 electron gives 2 Cr3 plus. Clear? So now in both cases that is 6 electron. Next step, listen, coming to the next step. Okay. Next step is balancing oxygen atom. Balancing oxygen atom. So now we balanced electrons. So in the first equation you can see there is no oxygen. So that is already balanced. So 6 Fe2 plus gives 6 Fe3 plus 6 electron. Okay. But in second equation you can see 7 oxygen atoms are the left side in Cr2O7 2 minus. So how you can balance oxygen in a redox reaction means, especially in half reaction method, you can add H2O for balancing oxygen. So for every oxygen atoms less, you can add H2O. For example, if 2 oxygen atoms are less at this side, you can add 2 H2O that side, like that. So here you can see 7 oxygen atoms are there left side, but right side no oxygen. So what you can do, add 7 H2O this side, right side. So how will be the equation? So Cr2O7 2 minus plus 6 electron gives 7, 2 Cr3 plus 2 Cr3 plus 7 H2O. Okay, 2 Cr3 plus 7 H2O. So now oxygen is balanced. Oxygen is balanced. So what is the next step? What is the next step? Next step is balancing hydrogen. Next step is balancing hydrogen. Okay, wait. Yeah. Okay. For balancing hydrogen, you can add H plus ions because this is in acidic medium. So again, in the first equation, there is no hydrogen, so you can write that as such. 6 Fe2 plus gives 6 Fe3 plus 6 electron. And in the second case, you can see how many hydrogen atoms are there. 7 H2. That means 14 hydrogen are present right side, and left side no hydrogen. So what you can do? Add 14 H plus left side. Okay. So Cr2O7 2 minus Cr2O7 2 minus plus 6 electron plus 14 H plus gives 2 Cr3 plus 7 H2O. Okay, clear? Now you balanced oxygen, hydrogen, everything. Okay, so now what is the next step means you can combine these equations. You can combine these two equations. So we are getting to the final step. Okay. Yes. Yeah. So now I'm going to combine this oxidation equation and reduction equation. So what are the reactant sides? 6 Fe2 plus Cr2O7 2 minus plus 6 electron plus 14H plus gives 6 Fe3 plus 6 electron plus 2 Cr3 plus 7 H2O. Okay, you can see 6 electrons are there on both sides, so you can cancel that. 6 electron cancel it. Okay, what are the remaining things? So Cr2O7 2 minus plus 6 Fe2 plus 14H plus gives 2 Cr3 plus 6 Fe3 plus 7 H2O. 7H2O. Done. That's it. Okay, so please check. 2 chromium left side, 2 chromium right side. 7 oxygen left side, 7 oxygen right side. Okay, 6 Fe left side, 6 Fe right side. So the equation is balanced. So this is your final balanced redox equation. Okay, so you have to follow certain rules, otherwise it is just like balancing a normal equation. So I'm repeating again, the very important thing in this particular topic is calculation of oxidation number. Okay, then identifying oxidation reaction and reduction reaction, that is very important. You should recognize which is oxidation, which is reduction very perfectly, otherwise your answer will be wrong. Okay, then you have to add a required number of electrons in case of oxidation and reduction. Okay, then balancing oxygen, balancing hydrogen, that's it. Clear? So I hope this topic is very clear, very perfect, crystal clear. So you can comment, you can mention in the comment box which topic you need next. Okay, so we can discuss that. So once again, welcome to Unique World Education Dubai. Okay, so we are here to provide sessions like this. Okay, based upon your requirement, we'll give sessions. Okay, so if you have any doubts, also you can come in comment box. Okay, so suggest your topics also, which topic you need next time. Okay, okay, so thank you all. Thank you. Bye. Take care all.